Welcome to MGT 301. This is increasing application availability with Amazon CloudWatch. I'm Greg Epple. I'm the global solution architect for observability. So I work with the CloudWatch and X-Ray service teams, and I work with our customers as well and partners. So the topic of this presentation, this session, is around how we can actually use CloudWatch to increase your application availability. And I think any discussion around availability, you pretty much have to talk about this quote I think our CTO is famous for here. So Werner Vogel has said many times that everything fails all the time. And I think this is a really important thing to keep in mind. Obviously, we want to architect across multiple AZs and multiple regions to increase overall application availability. But the fact of the matter is things will fail. They always will. And so it's also important to understand operationally how we can increase availability and reduce the amount of failures and the time that something is failing. And so that's really going to be the purpose of this talk, is to show how you can use the tools and the features of CloudWatch and increase your application's availability. And let's talk about availability for a bit, some definitions, some acronyms that you probably have seen out there. So MTTD, or the mean time to detection, this basically measures the amount of time it takes to detect an event, an operational event. We have the MTTI, which is the mean time to identification. And both of these are a subset, or they contribute to what most folks understand is one of the primary drivers for availability is MTTR, the mean time to repair. Some people call this mean time to remediation. And then you have what we call it MTBF. So a lot of acronyms here, but MTBF is the mean time between failures. So if MTTR describes the mean time of a failure, MTBF is basically the mean time between failures occurring. So ultimately, from an algorithm or from a formula perspective, this is basically how you'd measure availability. And some organizations, they don't measure this, and other organizations are very strict about availability. It's a measurement that they take. It's a KPI for the business. But ultimately, you calculate your MTTR, the mean time to repair, and you calculate the mean time between failure, and that's how you arrive at availability. I also think it's really important to actually understand what availability means when you hear 3 nines and 4 nines and 5 nines thrown around. So it's really important to understand what is your organization's availability, or what's the desired availability. People will often just say, throw around, we need 5 nines, without actually not taking into account or taking the time to understand what that actually means. So, 5 nines of availability effectively means less than 30 seconds of downtime a month. So you can't just throw a number out there, and if you don't, you have to be able to build and architect and operate with that availability in mind. So it's very important to actually understand what those nines mean and what your goal here is. And because we have to measure this, and if you're not measuring this, you're not going to attain that availability. So let's break down the failure. Let's talk through what typically happens in a failure, because this is key to understanding how you can leverage CloudWatch to increase that application availability. So a failure timeline obviously has a start and an end. And there's the detection, and so this was one of the first acronyms on the previous slide, the mean time to detection, MTTD. You may not actually detect, one thing to call out here, you may not actually detect something as soon as it starts. There might be a lag there. But for the purpose of this timeline view here, this slide, we have this detection occurring basically right as the issue starts. And so this is MTTD, as I described. And then we have the identification. So this is MTTI. And then you have the fix, and then you have the verification that the fix is in place, and then the issue is over. And so that's MTTR, right? Again, to understand your availability, you need to understand MTTR, and you need to understand the mean time between failures. Well, if we look at this timeline, what's the most expensive thing, or the most time-consuming thing here? It's the identification. The detection's important. The fix is obviously important because you need to resolve the issue, and you need to verify that it has been resolved. But where most folks spend most of their time is in the identification. And so I'm going to show you some tool in a demo of CloudWatch on how you can leverage our tooling to basically reduce and compress the identification, as well as the detection and the fixing, or the verification of the fix as well, which is ultimately going to help increase your availability. So, but we're going to take these 4 steps in mind here as we go through the rest of this presentation. So just remember MTTD, MTTI, and MTTR. detect, identify, fix, and verify. So let's talk about how we actually achieve this through Amazon CloudWatch. There's a large breadth of functionality within CloudWatch in all these categories, but let's start with the basics, right? We need to first collect the metrics and the logs and the traces, right? So tracing capabilities are provided by X-Ray. Those are visible within CloudWatch through Service Lens, which I'll talk about later. And then we have our CloudWatch stores logs and metrics amongst other things. So we need to make sure that we're capturing the logs, the metrics, the traces, and you're capturing those on your resources, because if you're not, none of this other stuff matters. So we have to make sure we have the basics there. Maybe an agent on a VM on-prem or on EC2 or on your containers. It's ensuring that you're sending the right logs. For example, in your Lambda functions, you're logging your have application logs there. So let's make sure that you have those things configured. Because this is going to ultimately lead to us being able to prevent future things from happening. So the next step is the detection, right? And so I have two items here. I have alarms and then a newer service, which again, alarms has been around for a while with CloudWatch. We have some new functionality called composite alarms, which I'll talk about and how that can help with the mean time to detection. We also have synthetics, which is a synthetic testing capability within CloudWatch. And so synthetics, again, both these are very proactive ways of detection. You could arguably put dashboards on here, for example. That would be a much more reactive way. So we really want to, on the detection category here, focus on proactive things that we don't have to go and look at a dashboard and understand there's an issue. We want algorithms and other services to detect that there are issues here. And then after the detection, now this is where we respond, right? And so I said in the previous slide that MTTR is comprised of a bunch of different things. So the detection, the verification, the fix, and the verification that fix has happened. Well, ideally, and we'll talk about this as well in this demo, is the perfect world, all your alarms and alerts would have auto-remediated runbooks and scripts that could run, so you wouldn't have to get involved in anything. Now, we don't live in a perfect world, so that's not realistic to have, but that should be your goal. Is if you go through and you build these alarms and you think about, well, if this alarm goes off, what do I do? Ideally, you want a computer to step in and remediate that issue, not a human. But the fact of the matter is, we have to get involved in these operational events. And so this is where other features and capabilities in CloudWatch come into play, like Service Lens, which you can, I think of as, or I describe it to customers as the observability hub. It's a hub service basically within CloudWatch, where we have a bunch of these purpose-built tools that kind of hang off of it. So log insights for log diving or log analytics. We have container insights, which combines log insights, but also gives you deep dive information, observability into your container-based workloads, whether that be EKS, ECS, Kubernetes, Fargate. And then we have contributor insights, which I'll talk about as well, which will help with top-end analysis of logs and DynamoDB tables. And then once we've responded and we put the fix into place and that issue is over, it's really important to actually analyze what happened, right? We don't want to continuously go through the same issue and over again. There needs to be, we want to prevent that repetition. So we want to be able to analyze what's going on. And so this can be through an RCA process, a root cause analysis. You may, some people call this the 5 whys, where you ask the question, well, why did this happen? And then you take that answer and you ask, well, why did that happen? And so you go 5 layers deep to try really to understand the root cause. So the important thing here is understanding these events after they've occurred, the fix is in place and everything's back up and running, taking the time to really analyze what happened. And that should really improve or help inform your operational posture here. So were there logs or metrics you're missing? Do you not have an alarm here that could have helped? And so trying to drive to that auto remediation as much as possible is ultimately going to help increase availability of your application. The other things too is just understanding operational metrics. What are the KPIs that you have? And again, I spoke to how a lot of customers, not all customers, but a lot of customers measure availability. So if you're taking that on as a KPI that you're giving a guarantee to your customer, it's pretty important for you to measure that. So understand what those metrics are, adding additional metrics or tweaking existing metrics is important. And so there should be learnings here. You should make sure that this is not tribal knowledge within a small team and that you're democratizing this knowledge across the organization here. and again, ultimately preventing this repetition from occurring. So this is where I'm going to jump into a demo here. I'm going to walk through quite a few things here, so I'm going to give you kind of a roadmap of what I'm going to be demoing in this talk here. And so the workflow that we're going to use here, or the workflow I'm going to go through, is I'm going to give you an overview of this pet adoption application. We built this application, which is available for you to use as well. Now, we'll talk about it at the beginning. But this is a pet adoption application, and I'll show the architecture, and we're going to trigger an operational event. So we're going to trigger an event. So it's going to be we're trying to simulate a day in the life of an operations person, an SRE, an architect. So we'll trigger an event. We're going to walk through how we detect and investigate this event. So just like I talked about that timeline of, what's the timeline of a failure? You have the start, you have the end, and then you have all that things in between. We're going to walk through that process and through that detection and, like I said, the investigation. We're going to manually recover from that event. And then I'm going to show you some things on how you can actually improve our detection and automate the recovery of these events, which is ultimately going to increase the availability of your application. Because remember, again, I'll repeat that availability is largely measured by the number of events that you have and the mean time of each of those events, or when you're in that failed state. So what we want to do is, ultimately reduce the number of these events from occurring, and then compressing each of those events so we get through much quicker. That's ultimately going to be what drives your availability. So I'll show you how we can improve detection and automate the recovery with some of our capabilities within CloudWatch. And then we're going to trigger the same operational event again, and I'll show you how that would auto-remediate as well. So I'm going to jump into the demo here. And so we have this this application. I'm going to actually show you this workshop just for your information. This is the workshop that the demo I'm going to show you is part of this workshop. So if you want to go do this yourself, you can go to observability.workshop.aws, and you'll have the site here where you can actually launch this yourself in your account, and you can go through all the capabilities that we have in CloudWatch and X-Ray as well, and get an idea of what we have to offer in terms of observability. So I'm going to just click over here in the prepare and install section here. And this is the overall application architecture of what we're going to have, or what my demo is based off of. So you can go launch this yourself. You can choose to run this on ECS or EKS. There's some serverless here, such as SNS and SQS. We have Elastic Beanstalk, Lambda, DynamoDB. So wherever you are on that modernization journey, whether it be VMs and containers or serverless, this should represent some portion of your application. And so this is the pet adoption site. Again, very simple looking site. Why pets? Because everyone loves pets. And so on here, again, we have a list of puppies right now. There's and other pets here. There's two filters here, a type and a color. So I'm going to go ahead and change this to a puppy and just filter the puppies. We can also, or we can do kittens and bunnies. We can also select the color of pet that we want, and it's going to, again, just filter that. The idea here is just a simple application that, somewhat representative of a real world application, and we can go ahead and take this pet home. We can adopt it. We'll put in our information and pay the adoption fee, and then we'll go ahead and proceed from there. We also see what pets have already been adopted, so we'll go to the adoption list, and we'll go ahead and look at these pets. So we have that information. So let's go into CloudWatch here, and let's go take a look at alarms. So that's going to be the first thing. The mean time to detection, like I talked about, is really key, in terms of how can we detect these issues faster and quickly. So I'm going to come into here. We have a bunch of alarms currently. I've already triggered the event, but we have a bunch of alarms already in an alarm state. And so we have this one alarm here called 2-second response breach. So it's detected that the latency of our responses has breached 2 seconds. And so we'll have the information within this alarm here that based off that metric is setting that alarm up. And so that alarm has gone off. But let's talk about compass alarms. This is a new feature that really can help us reduce the amount of alarm fatigue, amount of alarm noise, basically. So there's a lot of confusion generally when we have these alarms go off. So compass alarms allows us to select multiple alarms, like I just did. And I can apply Boolean logic. I can have ands, ors, nots. I can nest things in parentheses. So the idea here is, as opposed to having a bunch of alarms go off and notify me, I can have just one that's combined with multiple alarms. So I go through and I apply my Boolean logic, and then I set a notification here. And we'll talk more about how we auto-remediate here, but this would generally get sent to an email just by default. And so I could create my compass alarms here, And I have an alarm that has already been running for a while. And what this then tells me, or what allows me to visualize what alarms contributed to that composite going off. And I can have up to 100 alarms within the composite and up to 1,500 within the whole hierarchy. But you can see here as I scroll over time, I can see the points in time where that criteria, that Boolean logic was met. So the simple OR, and so that would basically help us understand or help reduce alarm fatigue. So let's go to the service lens, because we've detected there's an issue. I triggered one in the behind the scenes here, and we looked at alarms and how Compass alarms could help reduce that fatigue. And so we're going to go into service lens and take a look at this, because now we're in the investigation part of our troubleshooting here. We're trying to investigate, figure out what's actually gone wrong. And so I'm going to go into service map. And what we're going to see here is this is based off X-ray data, and it's showing up in CloudWatch, and we can see a representation, a graphical representation of our application. And there's some key information here, even if I can't read the text. We're in request mode, and so some of these circles are bigger and lines are darker, and that indicates where the requests are flowing through the system, which you can see right there. And so as we go through, we can change this to latency mode as well. So we can go into our latency mode, and now this will help us understand where the latency is flowing through the system. As you can remember, we just showed an alarm that was saying that we were breaching that 2 seconds. So this is going to help us investigate much, much quicker, which is really important in a distributed environment. If you have a very monolithic app, it's a little bit easier to understand where you should focus, but in a microservice architecture, you can waste a lot of time chasing things that don't matter to actually recovering from that event. So in this case, we have some information here where we can actually dive deeper. We know where we want to focus based on that we're encountering an alarm that has breached because of latency. So let's go ahead and let's go into this container, for example, because there's definitely a lot of latency going back and forth from that. And we're going to look at this dashboard. And so this dashboard is basically giving us information about this component on the service map. I get telemetry that's generated from the X-ray traces here. If I had alerts on this component, they would show up. I also get a node map. So I can see what upstream and downstream is actually occurring on this component that I'm looking at, this ECS container that's running our pet adoption site. So I can understand what's calling it downstream and what it's calling, or what it's calling upstream and what it's calling downstream. And I could go into other components here. So we could go into DynamoDB, for example, and take a look at DynamoDB. We get a very similar view. And as you can see, there's some alerts that have also gone off here as well. So again, more information to investigate this event. And as I scroll down here, we have our node map, and we can see there's nothing downstream from Dynamo. It's just a Lambda function and a pet search API that's running on Beanstalk calling our DynamoDB table, as well as some service-specific metrics. So from DynamoDB's perspective, it has other metrics that we may find valuable, so those get put onto this dashboard here as we look at our DynamoDB resource. And so we get these tailored dashboards for every resource that shows up on that service map there. And so as I go through here, I'm going to actually look at the traces now. So we can actually start to investigate these traces, individual traces. But I'm going to the trace view of service lens. I'm looking at my container, and I can apply a bunch of different filters. So I can apply errors, faults, throttling. If I'm annotating my traces, I can, with custom business metadata, I can apply those as filters. So we can only look at the traces that have bunnies, for example, or puppies if we wanted to. And we can see the response time for all three of these pet types are well over a second. So there's, again, the latency is not tied to just one of these pet types. So this information, these dimensions help you very quickly investigate and identify where the issues are. And so we can see here a P50 is pretty quick, our average response time, but our P95 and P99 is quite slow, upwards of 3+ seconds. So let's add this to a filter. We only want to focus on the slow traces. So we'll go from about 1 second plus. I'm going to add that response time filter. And if I scroll up there, you'll see that that's now been a filter that's been added. So now it's going to recalculate or re-get those traces. And we're looking at them based on the filter. So I'm going to pick the top one here. And we get some key information just right off the bat. When we look at this individual trace, we get this timeline breakdown of all these components and where it spent the most amount of time. And what we can see here is that the vast majority of the time was spent in DynamoDB, scanning a DynamoDB table, like 3 seconds of it. So that's quite interesting. We definitely need to look into that. There's also some errors here around S3, so we probably want to look into that as well. But if we're investigating latency right now, this is definitely, I don't want to call it a smoking gun yet, but it's something we definitely should look into. And we also get some of the logs that are associated with this trace. So you can see that the ECS pet site container has some custom logging, and so we can see some of this other additional application logging that's correlated automatically with our trace and our metrics. And so anyways, this is again, I think an area where we definitely want to focus and dive a bit deeper into this and figure out what's going on. So from here, I think what we should probably do is probably go look at our container first and see if there's any information we can find in our container, perhaps. So I'll just scroll up. Actually, let's go to Log Insights first. We're going to look at some of the application logs, and I'll just show you, again, Log Insights is one of those identification tools that can help you ultimately reduce MTTR. So right now, it's put the query in that I use to pull those logs, and so I can rerun that if I wanted to here. But I can go log diving and go into other application logs and write my own queries. So I'm going to remove this filter here in a second, but on the right-hand side, there's this help section that will give you our key operators and give you some information on how you can use those and you can apply those commands there. But I'm going to just write a simple query here. We're going to do a filter, and we're going to just look for the word error in all our messages or all our log events. So very, very simple, but just to give you an idea of kind of the workflow that you can use here. And I'm going to select some additional logs. I'm looking at about 5 or 6 right now. I can add up to 20 right now to this query here. So I'll add a few Lambda functions that are also involved in this site. And we'll go ahead and run the query. I'm going to just extend the time range here just so I can pull back a lot more logs. So we'll go back, say, about the last hour or so, and apply that and then run the query. And then from here, we'll take a second, and it's going to pull back a lot of logs here. So let's actually dive deeper into this and look at one of these individual log events here. It looks like it's coming from our Microsoft ASP.NET Core application. And it appears that it's the word error is showing up in one of the stack traces here. So, this may or may not actually be something that we care about. So we could filter this further, and we could continue to iterate on our log query and dive deeper and deeper into the logs here. That's outside of the scope of this presentation, but just to give you a sense of the type of workflow that you can use with Log Insights. And so that we're coming back to our trace, and we looked at Log Insights, and let's look at how Container Insights can help. So if you have a container-based workload, trying to understand like utilization and the logs coming off these containers is really important. And so obviously containers are a big part of my application. I've pulled up Container Insights here, and now I'm getting a visual representation of all the container clusters, whether it be ECS, Fargate, EKS, and I have multiples of those there. I'm getting a visual representation here. I've filtered to one pet site, the pet site cluster, which is running on EKS, and you can see I have 4 namespaces here as well as a bunch of services and pods. So I can go and filter down to any of these pods here from the top, and go get more information specifically on that node, whether it be a pod, a namespace, or a service. So you can see as I scroll down here to this CloudWatch namespace, I can see my FluentD pod, my Cloud Agent, and my Prometheus. And I can switch between memory mode and CPU mode. So the colors on these nodes will actually change based on the utilization of them. So these are all not heavily overutilized. You can see that this top here has changed color a little bit, because we're in memory mode and the memory is a little bit more, being used a bit more. But as those get closer and closer to 100%, they'll turn redder and redder, basically. And so now we can go into individual pod, and we can look at the performance of that pod, of that namespace, of that service, basically running on our cluster. So we get our CPU, our memory, network. Again, I'll just show you just how you can switch. And we also support Prometheus as well, so we can scrape metrics from Prometheus directly into CloudWatch. But you can see here, I'm looking at a specific pod, and I get my memory utilization. I can also go look at the logs for this. So I can select these pods, and I could go look at my application logs or my performance logs. So the performance data is actually ingested as a log first, and then we convert that to a metric. But I'm going to look at the application logs. Again, hopefully you're seeing this workflow, how this all ties together. But now we can go from Container Insights and dive into Log Insights and dive deeper into the logs coming off our container, ultimately to help us investigate this issue, because that's what we're trying to do right now. We're in that MTTI period there where we need to investigate, and we want to reduce that as quickly as possible. And we do that by using purpose-built tools like Container Insights, like Log Insights, and using Service Lens to tie all this together as kind of a hub of observability. And so we didn't, again, a quick look into Container Insights. We didn't find any smoking gun there, but this is definitely, it seems to be the scanning the DynamoDB table is causing some issues here. So I think we need to dive a bit deeper into this. And one of the key tools that we can use for this is something called Contributor Insights here. So if I go to Contributor Insights, I want to first talk about Contributor Insights about from a log perspective. So we have a log here that's basically a VPC flow log. And what Contributor Insights does, it helps do top-end analysis. And so we can see here, I'm looking at my source IPs. Those are my contributors. And I have over, and when I change the time here, over 3,000 of them. Now, you can't look at 3,000 things on a graph. It's just not going to be useful information. But I'm able to look at the top 10, top 50, top 100. And what you can see here is the top 3 are vastly generating more traffic than even, I would say, the 10th one. But if we go to, let's say, the top 50, for example, we're going to see that's just a small fraction of these contributors here. So when you have a lot of data, this is really, really helpful. So as you can see here, Contributor Insights, this is on VPC full logs here and showing us the top end, the top contributors basically in our VPC full logs, which is important because we have over 3,000 unique IPs. So it's very difficult to understand what's impacting this. During an operational event, where are the top contributors to an event perhaps? And so this can be used on logs, it can be used on common log format, on JSON logs. This can also be used on DynamoDB. And so we can go look at DynamoDB table here. You can see that on the left-hand side with the little icon, the cube icon. And we can look at our DynamoDB tables, and this will actually give us information about how we're consuming what our consumed throughput units are the contributors that we're actually measuring within Contributor Insights. So we could use this to also look at, is that impacting the scanning that we're doing, for example, the long times it takes to scan these DynamoDB tables. So we could go into there and actually understand better about how that DynamoDB table is operating and performing, and then tweak our settings on the throughput and the auto scaling there to help improve the performance there. All right, so let's go take a look at actions. I talked about how we want to ultimately get rid of the investigation, just automatically remediate this. And so part of that is making sure you have an action on your alarm. You can see we have an alarm here, and it has a notification, but there's no subscription. So people often put email here. What you ultimately want to do is replace the email subscription to this topic, and you want to actually create a Lambda function. And so that Lambda function would then be responsible for running whatever script you need or calling API or CLI to basically remediate this issue automatically. So I would go through here, create a Lambda function. Once I've learned what this issue is, I would create a Lambda function and then actually assign that to my alarm. And that's ultimately going to help reduce that mean time to investigation because we're going to remediate this automatically. The other part that we can use, the other feature we can use to really improve our detection is CloudWatch Synthetics. So Synthetics is basically a way for us to do end user testing. So I can create there's a bunch of blueprints here, and I'll create what we call a canary. So you can write your own script as well if you want to, but these blueprints basically do that for you. So I'm going to say I'm going to create a heartbeat test here, a heartbeat canary. I'm going to put my application in here, and it's going to update the script. But effectively what this will do is it will create a screenshot, take some logs, and set up an alarm for me so I can actually, if this fails from an end user perspective, I can be alarmed on that. And you could tie that into a Compass alarm or have an auto-remediated script like I just showed you attached to this. So I'm just showing you an example where you can actually set up an alarm here. So you have different thresholds and averages and the conditions. We can also set up a notification. So just like I showed you how to attach a Lambda function to your alarm, you could do the same thing for alarms coming off of here. And so I already have a bunch of canaries that have been running for a while, so I can, in the interest of time, show you one of those existing ones. But I can click any of these points on the graph on the time series here and look at the individual test. And you can see in this test here, it's actually taking multiple screenshots as I've navigated this pet adoption site here. So I get a screenshot through each step that the user takes in the application. I get an HTTP archive file, which also gets stored in S3. But that's going to basically break down how long did it take to download like these different assets in CSS and style sheets and images in JavaScript. So I get a breakdown and the request headers here. I also get a log of the actual canary, so I can log information here. And then these are ultimately producing metrics. So Lambda is what's executing Synthetics under the hood. But I can go into metrics here, and I can go to my CloudWatch Synthetics namespace over there. And I can look at this through different dimensions. We'll look at the by canary, and I can look at my UI canary that I've set up, and I have the success percent and the duration. So how many times was it successful, and then what was the duration of each of those tests. So I can actually create that and then create an alarm off of this. Again, we can drive a Lambda function off this alarm breaching the threshold, or we can make this as part of the composite alarm. So it's just an example of how you can leverage CloudWatch Synthetics there. Now let's move on and talk about what I just showed you, because I showed you a lot in a small period of time here. So I just want to recap what I showed. I showed you an application where I had triggered an operational event, right? So an alarm had gone off. Again, we looked at those alarms and we looked at how we can improve the detection through composite alarms and maybe reduce some of the alarm noise, the alarm fatigue. But we showed an operational event occurring. I showed you how you can increase your application availability, by doing a few things, by reducing your mean time to detection with CloudWatch synthetics and composite alarms. You're going to be able to have more, reduce the alarm fatigue. You'll be able to detect and understand what's going on quicker if you can create composite alarms. And CloudWatch synthetics are going to just give you a better idea of what's going on and detecting issues. So as opposed to waiting for CPU to go really high, memory, disk utilization, that low-level telemetry, you can create more end-user-based testing and actually have alarms associated with that. So you can have a much more representative view of what your users are doing and detect on any potential issues there. So CloudWatch synthetics and composite alarms are ultimately going to help you reduce MTTD. I also showed you a bunch of tools and that will help with reducing MTTI, the mean time to investigation. So as I mentioned, when we broke down that failure timeline, the investigation is the slowest part. That's the most time consuming here. And so it's really important that you have purpose-built tools. And I talked about how Service Lens is an observability hub, and we have container insights and log insights and contributor insights. There are all these purpose-built tools that kind of are spokes to this observability hub here. So these set of tools are ultimately going to help you really reduce that mean time to investigation. But I think the biggest thing to, frankly, increasing your application availability, and we talked about this briefly here, is creating alarm actions, is making sure that you don't even have to get involved. And that's not maybe realistic to do this for every single alarm that you have, but this should be a continuous improvement that you have operationally. Your operational posture should be continuously improving. So as you go through these events, make sure you do root cause analysis, make sure you're tracking the right metrics, and understand how you can do better the next time. And so a big part of that is really making sure you have the right alarms and having alarm actions. So, having that alarm associated with an SNS topic, which calls a Lambda function. That Lambda function is your remediation. And so that's ultimately what's going to really reduce MTTR, but it's really a combination of all these things and making sure you have a culture of continuous improvement from an operational perspective. So that's my presentation, and I hope you learned a little bit of how you can leverage CloudWatch to increase the availability of your application. There's a lot of functions or a lot of features and functionality within CloudWatch that I believe is ultimately going to help you increase your availability. And hopefully I showed you some of the steps and the processes and mechanisms that you can use to ultimately accomplish that. So I wanted to thank everyone for listening to my presentation, and have a great rest of the day.